Hi students, today we are doing the May June paper 4 of 2024 variant 1. We have done the first 4 parts in the previous lecture. You can go watch the previous video, and now we are starting with question number 5. Okay, so the question number 5 is lead bromide is an insoluble salt and is made by precipitation. Name 2 aqueous solutions that produce a precipitate of lead bromide when they are mixed. So we need to form lead bromide by precipitation reaction. Remember that in precipitation reaction, we will use 2 soluble salts as reactants. 2 soluble salts. So in precipitation reaction, there is no involvement of acid, there is no involvement of an alkali or a base, not at all, just 2 soluble salts. So to prepare the lead bromide, the first soluble salt must have lead in it, and the second salt must have bromide in it. As for the lead, we can write lead nitrate because all the nitrates are soluble. And for bromide, we can use sodium bromide because all the salts of sodium are also soluble. So we can write here lead nitrate and sodium bromide. Describe how to produce a pure sample of lead bromide from the mixture of aqueous solutions in A1. Now, in A1, when we mix lead nitrate and sodium bromide, we get lead bromide, a mixture of lead bromide and the other substance. Now, when we get these lead bromide precipitates, how can we remove them from the mixture? Very simple, we can remove them by doing the filtration process. So first of all, we'll filter the PPT. We'll filter the precipitates. And after filtering the precipitate, we'll wash the residue. Wash the residue and dry them between the folds of filter paper. Between the Next question. Write an ionic equation for the precipitation reaction which produces lead bromide. Include state symbols. Now, to produce lead bromide, we'll write the ionic equation. Ionic equation involves the positive and negative ion which are present in that specific substance. Here we have lead bromide. So the positive ion will be Pb2 plus there will be bromide ion Br negative, and these two ions will combine to form PbBr2, which is lead bromide. Now here we have two bromide atoms. So we'll balance the bromide ions. We'll take 2 bromide ions. So Pb2 plus 2 bromide negative, 2Br negative gives PbBr2, and we'll write the state symbols. The ions are always aqueous and they're giving us the precipitate lead bromide. So precipitate is a solid. When iron sulfate crystals are heated strongly, sulfur dioxide gas is given off. Describe a test for sulfur dioxide gas. Now, if you don't remember the test of sulfur dioxide gas, then you have to learn the tests from the data sheet. So learn the tests of gases from the data sheet, which is given to you in paper 6, at the end of the paper 6. So sulfur dioxide can be tested by using acidified potassium manganate, As we know that the potassium manganate color is purple, so due to the presence of sulfur dioxide, its purple color changes into colorless. It changes from purple to colorless, or you can also write that the purple color fades. Complete the equation for the thermal decomposition of hydrated cobalt nitrate. We have to balance this equation. For our simplicity, the reactant is already balanced. What we have to do, we have to see the substances on the reactant side, the amount of the substances on the reactant side, and we have to balance them on the product side. For cobalt, you can see we have 2 moles of cobalt, so we'll write 2 over here. For nitrate, for nitrogen, we can see the nitrogen NO3 is bold twice, which makes nitrogen 2. And this nitrate is 2 molecules. We have 2 molecules of cobalt nitrate. So 2 into 2, it makes it 4. 4 nitrate. So here we'll write 4. Now as for the water, we have 4 molecules of water which contains 2 hydrogen ions. So each water molecule contains 2 hydrogen atoms. So 4 water molecules contain 2 into 4 hydrogen atoms, which makes them 8. So we'll write 8 over here because we have 2 molecules of the crystals. In 4 water molecules, there are 8 hydrogen atoms and there are total of 2 crystals. So 8 hydrogen atoms multiplied by 2 because we have 2 crystals. So which makes it 16. Next question. Hydrated cobalt sulfate produces water when it is heated. A student does an experiment to determine the value of X in cobalt sulfate, hydrated cobalt sulfate. So we need to find out the value of X in this crystal, hydrated cobalt sulfate. A student weighs a sample of hydrated cobalt sulfate. Student heats the sample of hydrated cobalt sulfate. Student weighs the remaining solid after heating. Means a student weighs the anhydrous copper sulfate after the water has been evaporated. Describe what else students should do to ensure that all the water has been given off. No other substances are required. So what will the student do to make sure that all the water has been given off? All the water has been evaporated. A student reheats and reweighs. Reheat and reweigh the substances. Or you can also say, repeat the step, repeat the heating, and note down the mass until no further change. Until no change occurs in the mass. Until there is no change, we have to keep heating it so that all the water evaporates. In an experiment, 1.405 gram of hydrated cobalt sulfate is heated until all the water is given off. So the mass of hydrated cobalt sulfate is given. The mass of copper sulfate is 0.775. Means the hydrated crystal's mass is 1.405 and after heating, the anhydrous copper sulfate just remains to 0.775. Now we have to find out the value of X. To find the value of X, you have to do 3 steps. First, you will find the number of moles of the salt, whatever salt is given to you. Here, the salt is cobalt sulfate. So first we'll find the moles of cobalt sulfate. Then we'll find the moles of water. And then we'll divide the moles of salt with the moles of water with the moles of salt. So we'll do H2O divide by cobalt sulfate moles. So these are the three steps which we use to find out the value of X of any substance. Find out the moles of the salt, moles of the water, and then divide. Calculate the number of moles of cobalt sulfate. Now here we'll use the formula. Moles is equal to mass over molar mass. The mass here is given to you in the question, which is 0.775. The mass of cobalt sulfate. Then we will find out the molar mass of cobalt sulfate, which is given to us in the question, and 155. So 0.775 divided by 155, the answer comes out to be 0.005 moles. These are the moles of copper sulfate, cobalt sulfate. Now find the mass of water. We have the mass of the crystal, which is 1.405, will minus the mass of hydrated cobalt sulfate from it, and it will give us the mass of water. So the mass of water will be 0.63. We have the mass of water. Now we will calculate the number of moles of water again by using the formula. Moles is equal to mass over molar mass. Mass of the water is 0.63 divided by the number of the molar mass of water is 18 given in the question. So 0.63 divided by 18. The answer is 0.035. Now here we have the moles of water. To find the value of X, we'll do the moles of water divided by the moles of cobalt sulfate. So we'll do 0.035 divided by 0.005. And the answer comes out to be 7. The X is always a whole number. So it is 7. So it means that the formula of the crystals will be cobalt sulfate COSO4.7H2O. Let's do the next question. This question is about metals. Figure shows a blast furnace used to extract iron from its ore. Now this is the apparatus. This is the blast furnace. And as you can see, the waste gases are going out and the hot air is entering into the furnace. There are two layers which go out of the furnace. So there is a slag and there will be a second layer, molten iron, which will be separated, which will be taken out from A. Coke and iron ore are added at the top of the blast furnace. Name one other substances that is added at the top of the blast furnace. So at the top of the blast furnace, we add coke because it reduces iron. It reduces iron oxide to get iron. Then we are using the iron ore from which the iron will be extracted. The third thing we use in the blast furnace is the limestone. The limestone is used to remove the impurity, which is sulfur dioxide. So name other substance which is added. It is limestone or calcium carbonate. Name the substance that leaves the blast furnace at A. It's molten iron. Slag is produced from an impurity in iron ore. Name the impurity in iron ore that is converted into slag. I just told you right now that the impurity in hematite ore is silicon oxide or silicon dioxide. So we will name it silicon 4 oxide, or it can also be written as silicon dioxide. Do not write the formula when they ask you about the name of the substance. Name two substances that react together to produce high temperature in the blast furnace. Note now, to increase the temperature in the blast furnace, we use coke, which is carbon, and we burn it in oxygen so that it produces carbon dioxide, which increases the temperature of the furnace. Name two waste gases that leave the blast furnace. So the two waste gases which leave the blast furnace, first will be carbon dioxide. Second will be the gases which are present in the air, like nitrogen, like argon. So one of the gas will be carbon dioxide, and the second gas will be from nitrogen or argon, anyone. Zinc is produced from zinc oxide in a furnace. Now this is the extraction of zinc. Zinc is produced as a gas. It then forms molten zinc. So first it is produced as a gas and then it turns into molten zinc. Suggest why the zinc produced inside the furnace is a gas. Anything is a gas because of the temperature. We'll write the temperature of the furnace. The temperature of the furnace is more than the boiling point of zinc. Because here, the zinc is converted into gas after boiling. So once the boiling point of zinc has been reached, then after that, it's a gas. After boiling point. After boiling, it is a gas. So the temperature of the furnace is more than the boiling point of zinc. That is why it is a gas. State the name of the physical change that occurs when gaseous zinc is converted into molten zinc. That's called condensation. Zinc is used to coat iron to prevent rusting. Name the process used to coat iron with zinc as a method of rust prevention. When the iron is coated with zinc, it is called galvanization. When the zinc coating is scratched, the iron underneath does not rust. Explain why the iron underneath the zinc does not rust. Now, as we all know, that zinc is more reactive than iron. So it protects the iron by losing its electrons in preference to iron. So it gets oxidized very easily. So we will write, as this question is of 2 marks, so in first point, we will write the zinc is more reactive than iron. And in the second point, we can write that zinc oxidizes, or we can write that zinc loses electrons, or that zinc reacts. We can write any of these three things, then in preference to iron. So zinc oxidizes quicker than iron, or zinc loses electrons in preference to iron, or zinc reacts in preference to iron. Anyone? Zinc oxide neutralizes both acids and bases. State the general name given to the oxides that neutralize both acid and bases. They are called amphoteric. Amphoteric is a substance which reacts with acid and base both to give salt and water. When zinc neutralizes aqueous sodium hydroxide, sodium zincate is formed. The formula of zincate ion is ZnO2 2-. Deduce the formula of sodium zincate. Now to deduce the formula, we have to write the ions first. Sodium ion is 1 positive and zincate ion is ZnO2 2 negative. So first we'll write the ions of sodium and zincate. The zincate ion is given in the question. Then what we will do, we'll use the crossover method. We'll write their valencies in cross, their charges in cross. So with sodium, it will be Na2, ZnO2. That's the formula. Next question. Name the zinc compound that forms zinc oxide when zinc oxide neutralizes dilute sulfuric acid. So when zinc oxide reacts with sulfuric acid, which zinc compound forms? Zinc reacts with the sulfate to form zinc sulfate. So we'll write the name of the compound, zinc sulfate. Again, I'm saying do not write the formula. Write the name. Next question. Many organic compounds contain carbon and hydrogen only. Organic compound A has the following composition by mass. Calculate the empirical formula of a compound A. Now, the empirical formula shows us the simplest whole number ratio between the elements in a compound. How we'll calculate it? We have two substances, two percentages over here of carbon and hydrogen. So we'll write carbon ratio hydrogen. Carbon will be 82.76. And hydrogen is 17.24. We'll divide both of them by their atomic masses. So carbon atomic mass is 12 and hydrogen atomic mass is 1, which makes carbon 6.90 and hydrogen will be 17.24. Now, the next step is that we will divide both of them by the least number. So the least number here is 6.90. We'll divide both of them by 6.90. So it will be, carbon will be 1 and hydrogen will be almost 2.5. Now, as you can see, hydrogen is not a whole number. It's coming 2.5. So what we'll do to convert hydrogen into whole number, we'll multiply both of these numbers by any number so that we get the answer. We get the answer in the whole number. So 2.5, let's see if we can multiply this 2.5 with 2, we're getting the answer 5. So we'll multiply it with 2. So carbon will become 2 and hydrogen will become 5. So the answer is, empirical formula is C2H5. Next, compound B has the empirical formula CH2 and the relative molecular mass of 70. Determine the molecular formula of compound B. Now to find the molecular formula, we have this equation, that molecular formula is equal to N into empirical formula. We have to find this number N. N is any whole number. So once we get the value of N, we can multiply it with CH2 we can multiply this N with CH2 to find the molecular formula. Now, to find the value of N, we will do the molecular mass divided by empirical formula mass. The molecular mass is given in the question, which is 70. And for the empirical mass, we'll see the mass of this empirical formula, which is given to us. It's CH2. So carbon will be 12 plus hydrogen 1 into 2. 12 plus 2, it comes out to be 14. So here we'll do 17 divided by 14. 70 divided by 14, it's 5. So N is 5. What we'll do? Next step, we will multiply this N with the empirical formula CH2. N is 5. We multiply it with CH2. So the molecular formula will be C5H10. Next question. Figure shows a section of polymer Q. This is a polymer. Draw the displayed formula of the monomer that forms polymer Q. Now, to draw the monomer, we have to find the repeating unit, means the two carbons which are repeating themselves. So here, this thing of 2 carbon is repeating itself in the next part. So this is its monomer, a repeating unit, but with a double bond in the middle, because this is an addition polymer. So addition polymerization has a double bond. When you see a carbon chain, it means it's addition polymer. So everything will remain the same. Like on the top, there is CH3, and at the bottom, the hydrogens are attached. Hydrogen atoms are attached with 2 carbons. And in the middle, there will be double bond. So that's the monomer. Name the monomer used. Now to name this monomer, we will number the carbon chain. So we have 1 carbon, 2, 3, and 4. It's a 4 carbon with a double bond, so it means it should be butene. And the double bond is present on carbon number 2 and 3. So its name will be but-2-ene. Propene can be produced by heating C11H24. The products of the reaction are propene, hydrogen, and one other product in a 1:1:1 mole ratio. It means that the answer, the products which we are getting, they will be 1 mole, 1 mole, and 1 mole. So one of the product is C3H6 propene. The other product is H2. What will be the third product? So if we see there are in the product, we have C3, 3 carbons. So we'll minus this 3 with 11. 11 minus 3, it's 8. So it will be C8. As for the hydrogen, we have 6 plus 2, 8 hydrogen. So for hydrogen, we will do 24 minus 8. And it comes out to be 16. So the answer is C8H16. Carboxylic acids and esters contain carbon, hydrogen, and oxygen. An ester X and a carboxylic acid Y both contain 3 carbon atoms. An ester X and a carboxylic acid Y means are these 2 different compounds? Ester X and carboxylic acid Y both contain 3 carbon atoms. X and Y have the same molecular formula. State the name given to the compounds with the same molecular formula but different structural formula. Very simple. They are called structural isomers. The compounds which have the same molecular formula but different structural or displayed formula. They are called structural isomers. Esters are made by reaction between carboxylic acid and alcohols. So carboxylic acid and alcohol, when they combine with each other, they form ester. The ester X is methyl ethanoate. We have to write the name of the carboxylic acid and the alcohol used to make this ester X. Now, to identify the name of the alcohol, we'll see the aryl one. So if it is methyl, so it means that the alcohol used will be methanol. And for the carboxylic acid, we will see the OH part. So if the OH part of the ester is ethanoate, it means that the carboxylic acid used will be ethanoic acid. That's how we can identify which carboxylic acid and which alcohol is used. Alcohols give the aryl part and carboxylic acids give the OH part in the esters. Draw the displayed formula of carboxylic acid Y and name the carboxylic acid. Now, carboxylic acid Y, as it is written in the question, that carboxylic acid Y contains 3 carbon atoms. So, a carboxylic acid with 3 carbon atoms, its name will be propanoic acid. Name will be propanoic acid. And its structure will be 3 carbon atoms. On the last carbon, we can attach C double bond O, OH, which is the carboxylic functional group. And for the rest of the carbons, we'll complete the valency, 4 valency of each carbon by hydrogen. So it will be like this. This is the displayed formula. So it will be CH3, CH2, COOH. This paper is done. You can see the rest of the parts, the previous parts, first 4 questions in the previous video. You can watch it. And we'll do the next variant in the next class.